Day 1 of 90. Over this year you will build real security tools, network scanners, password crackers, packet sniffers, and custom exploit frameworks. But every serious tool you write depends on having the right foundation underneath it. Today we build that foundation, a clean, isolated, professional Python security environment. This is the setup that separates people who study security from people who actually practice it. Stay for the whole video. The last step reveals something most beginner tutorials skip entirely. Start with Python itself. In your terminal, run Python 3 version. You need version 3.10 or higher. Security libraries like Scapy drop support for older versions fast. On Ubuntu or Debian, run sudo apt update sudo apt install python 3 pip python 3 venv. On Mac with Homebrew, run brew install python 3. On Windows, download from python.org and on the installer screen, check the box labeled Add Python to Path. Skipping that box causes errors that confuse beginners for hours. After installing, run Python 3 version again to confirm. Here's the rule professional security developers never break: never install security tools globally on your system. The reason is dependency isolation. Two different tools might need conflicting versions of the same library. One wants requests 2.28, another needs 2.31. Virtual environments solve this cleanly. Run Python 3 venv security_env to create your isolated workspace. Activate it. On Linux or Mac type source security_env/bin/activate. On Windows type security_env /scripts/activate. Your terminal prompt will change. That prefix is your confirmation you're now inside the sandbox. Everything you install from this point stays isolated here. With your environment active, run pip install requests scapy cryptography python map paramiko. Here's what each one does. Requests is your HTTP client. Every web scraping, web recon, and API interaction task uses it. Scapy lets you build raw network packets from scratch. You'll use it to craft custom probes, sniff traffic, and analyze protocols at the byte level. The cryptography library provides battle-tested implementations of AES, RSA, and hashing algorithms. Python map wraps the map scanner so you can automate port scanning in code. Paramiko handles SSH programmatically, critical for automation and authorized brute force simulations. Immediately after installing, run pip freeze requirements.txt. This command writes every installed package and its exact version into a plain text file. Open it. You'll see entries like requests == 2.31.0 and cryptography == 41.0.3. That precision matters because security research has to be reproducible. When you need to run the same tool on a different machine, a VPS, or a team member's computer, run pip install requirements.txt and it rebuilds your exact environment. This file also documents your tool's dependencies for reports and code reviews. Make it a reflex for every project. Verify your install quickly. Inside Python, run import requests, scapy, cryptography, map, paramiko. A clean import with no errors means everything is ready. For version checking from the terminal, use this pattern, Python 3 c\import requests, print, requests, __version __. That C flag runs a quoted string as Python code directly. It's faster than opening an interpreter and useful for debugging in automated scripts. You'll use this pattern constantly throughout the challenge whenever a library behaves unexpectedly and you need to confirm exactly what version is running. Now organize your project directory. Run mkdir p security_project/ recon exploits crypto network utils. Those subfolders map to the categories of tools you'll build across this challenge. Inside security_project, create a .env file. This is where you store API keys, target host addresses, and credentials for authorized test environments. Immediately open .gitignore and add .env on its own line. This is not optional. One accidental commit with real credentials exposed publicly is enough to compromise your accounts, expose your clients, or trigger legal consequences. Install python-dodenv by running pip install python-dodenv. You'll load that .env file in scripts using from dodenv import load_dodenv, load_dodenv. Let's run a real test. Create test_env.py and write this, from cryptography.fernet import fernet, key equals fernet.generate_key, cipher equals fernet, key, token equals cipher.encrypt, battack at dawn, print, cipher.decrypt, token. Run it with Python 3 test_env.py. You'll see the original plaintext printed back. What just happened? Fernet used AES 128 in CBC mode with PKCS7 padding to encrypt your message, then HMAC SHA-256 to authenticate it. That's authenticated encryption, the same standard used in production applications. You didn't write a toy. You wrote working cryptographic code on day 1. Day 1 done. Virtual environment, core security libraries, locked requirements file, organized project structure, secrets management that won't leak credentials. That's a professional setup, identical to what working security engineers use. Tomorrow on day 2, we write our first Python network scanner from scratch. Subscribe so you catch it.